Welcome to today's lesson on how do you solve two-step inequalities. So the good news about today's lesson is that you solve an inequality, a two-step inequality, the same way you would solve an equation. So if you did really well with the last unit, if you've been paying attention, doing all your homework, staying caught up, then you'll do really well with two-step inequalities. If you haven't been, then now is a good time to maybe view this as extra practice when it comes to solving two-step equations or inequalities. So it is just like you solve an equation, but there are a few special things you need to consider with inequalities. Number one is what we spent the last 2 days looking at, and that is we need to look carefully at the inequality because there are times when you will have to flip the inequality symbol. So hopefully you can take a second, just think to yourself, when is it that we would have to flip an inequality? So you remember from the last 2 lessons. The second thing that you have to do with inequalities is we also need to graph the solution set. Okay, we can't just say what the solution is, we need to graph it as well. All right. So hopefully if you were thinking to yourself, what do we need to do to flip an inequality? Well, an inequality symbol needs to be reversed, aka flipped, whenever you multiply or divide both sides of the inequality by a negative number. That by word there is very important. When you multiply or divide by a negative. Not if there's a negative in the problem, but when you multiply or divide by a negative. So in these 2 examples, okay, if you look for the variable, if it is teamed up, quote unquote, with a negative number, we'll have to flip it. All right, so in this example, it's kind of hard to see on my video, but it should be easier on your paper. We have a negative 2x plus 5 is greater than 15. Because the negative 2 is teamed up with the x, we know that we're going to flip the inequality. Same with example 2, we have x over negative 8 plus 5 is less than or equal to 13. Because the negative sign is teamed up with the variable, we know that we're going to flip the inequality when solving it. So as your first you try, I would like you to analyze each inequality. You have 6 of them here. If the inequality were, or if it is an inequality where you need to flip the symbol, then circle that inequality symbol and write above it what it will look like after the inequality has been solved. Do not work the problems. Go ahead and try the problems on your own now. You are just circling the inequalities of the problems that you will have to flip. Okay, remember to look for the ones that are teamed up with negatives. Go ahead and try. And when you're done, you can unpause the video and check your answers. All right. Hopefully you circled numbers 2. Because of the negative x, we know that's going to flip and become a greater than sign. Hopefully you circled number 3. Because of the negative sign being teamed up with the r over 2, I know I'd have to multiply by negative 2, and that's going to become the less than sign. Hopefully you circled number 4. Okay, I always like to say that whatever sign comes before it stays with it, so that's a negative 11a. So I'd have to divide by negative 11, and it's going to flip the sign to a less than or equal to sign. Number 1 is fine. Even though there's a negative in front of it, it's not teamed up with the variable, so don't have to worry about 1. 5, the only negative is on the other side, but we would be dividing by 3. The negative's not paired up with the variable, so it can't be number 5. And number 6, same idea. The negative comes first, but it's not teamed up with the variable, so you can't flip 6. Awesome. So now when it comes to actually solving two-step inequalities, the steps are very similar to two-step equations. Number 1, what is happening to the variable? Okay, what's the do? What are the inverse operations to undo it? And then do I need to flip the inequality sign? Are you multiplying or dividing by a negative? So in this example, you see we have negative 3x plus 5 is less than or equal to negative 16. Your first step is to undo the plus 5 by subtracting 5. And you get negative 3x is less than or equal to negative 21. We divide both sides by negative 3. and we get x is greater than or equal to 7. We had to reverse the sign or flip the inequality because we divided by a negative 3. Awesome. If you're good with that, flip the paper over. There are 6 problems on the back. We are going to do the left 3, and you are going to do the right 3. All right, let's start with guided practice number 1. 3x plus 4 is greater than or equal to 16. Our first step is to get rid of the plus 4 by subtracting 4. On both sides, your work should look identical to mine. That will leave me with a 3x is greater than or equal to positive 12. This is then 3 times x, so we undo the multiplication with division. I'm going to write the answer up here. It is x is greater than or equal to positive 4. So then when we graph it, we just got to put a positive 4 somewhere. Put my positive 4 right here, which means 5, 6, and 7 go to the right. 3, 2, and 1 go to the left. I have a greater than or equal to sign, so I know it's a closed circle at 4. And I shade to the left. And that's my answer. Let's go on to guided practice number 2. This time we got 7 minus 2x is greater than 11. Immediately you should recognize that this minus sign belongs to the 2x. So since the negative sign's paired up with the variable, I know that my sign is going to flip. Okay, I know it's going to eventually become a greater than sign. So first thing, this is a positive 7. So to get rid of positive 7, we need to subtract 7 from both sides. Once you subtract 7 from both sides, we'll be left with negative 2x is greater than 4. 11 minus 7 is 4. We're then going to divide both sides by negative 2. Since we're dividing both sides by negative 2, we know we're going to have to flip the sign. So I'm going to write the answer up here. It's going to become x is less than negative 2. So when I fill out my number line, I'm going to put negative 2 right here, which means to the right it's going to be negative 1, 0, positive 1. To the left is going to be negative 3, negative 4, negative 5. And I'm going to graph it with an open circle at negative 2, shading to the left. All right. Moving on to the last guided practice question. X divided by 2 minus 5 is less than negative 8. First thing I need to do is get rid of the minus 5 by adding 5 to both sides. I get x over 2 is less than negative 3. Then I'm going to multiply both sides by 2. And here's the tricky part. I now have negative 3 times 2. So I'm multiplying a negative over here. Do I flip the sign knowing that there's a negative in my multiplication? The answer to that is no. We don't flip the sign. The reason is we are not multiplying by a negative, right? We're multiplying by positive 2. There just so happens to be a negative involved, but we're not multiplying by a negative. There's just a negative involved. Hopefully that difference makes sense to you. So this just becomes x is less than negative 6. We don't flip the sign. Create our number line. Negative 6, negative 5, negative 4, negative 3, negative 7, negative 8, negative 9. We're going to have an open circle at negative 6, shading to the left. All right. I'd like you guys now to pause the video and try numbers 1, 2, and 3 on the try side. When you're done, you can unpause your video and check your work with me. Welcome back. Hopefully you have finished examples 1, 2, and 3 on the try side. We're going to go over them quickly. So for number 1, our first step would be subtracting 5 from both sides. That will leave us with a 4x is less than 28. Divide both sides by 4, and we get x is less than 7. So if I make my number line 7, 8, 9, 10, 11, 6, 5, I'm going to have an open circle at 7, shading to the left. For number 2, hopefully you realize that this negative sign belongs to the 3x. So my first step is going to be subtracting 6 from both sides and getting negative 3x is less than or equal to positive 3. 9 minus 6 is positive 3. We're then going to divide by negative 3 on both sides. Because I'm dividing by a negative, I know my sign needs to flip. And it becomes x is greater than or equal to negative 1. So I create my number line. Got negative 1, 0, 1, 2, 3. Negative 2, negative 3. Put a closed circle at negative 1, and I shade to the right. And then the last one, x over 4 plus 3 is greater than or equal to negative 7. I'm going to subtract 3 from both sides. So I get x over 4 is greater than or equal to negative 10. Multiply both sides by 4, and we get x is greater than or equal to negative 40. Yes, there's a negative in the multiplication, but just like the previous example, I am multiplying by a positive number, so the sign does not flip. So I got negative 40, negative 39, negative 38, negative 37, negative 36, negative 41, 42. Closed circle at negative 40, shading to the right. All right, hopefully you did well with this. You will have practice to work on afterwards. Please just read the digital agenda to find out. Thank you, everybody. Have a wonderful day. I'll see you next time.